In this lesson we're going to have a look at how to use Pythagoras to calculate one of the smaller sides on the triangle, i.e. not the hypotenuse. Now to help us out, we'll just have a wee look at this idea here again. Now what we were saying before is, we were saying to get area 1, i.e. c squared, you would add area 2 and area 3 together. Now if we're wanting to work out a smaller side like A or B, then if we think about area 2, to get area 2 then you would need to subtract area 3 from area 1. And to get area 3 you would need to subtract area 2 from area 1. So you're always subtracting from area 1 basically. So if I put that back and have a look at this idea here, we've got a triangle with 12 and 7. 12 is the hypotenuse, 7 is one of the smaller sides, and we're trying to work out x. So Pythagoras' theorem is set out like this, but that's when you're trying to work out the hypotenuse. I'm not looking to do that, I'm looking to work out one of the smaller sides. So in this case, you can use A or B. I'm going to write A squared here, but I need to subtract from the biggest side. Okay, so that's going to be C squared, take away B squared. So it's a subtract and not an add that you do. The rest is just filling in information. So C is 12 and B is 7 in this case. So A squared, or sorry, x squared in this case, x, we're going to use x, is 12 squared, take away 7 squared. X squared is equal to, that's 144, take away 149, sorry, 49. And then x squared is equal to 95, and then if you just square root that as before, you get an answer of 9.75 to 2 decimal places. So the idea is very similar, except you do a takeaway sum, and remember to take away from the biggest side squared first, or else you'll end up with a negative value. Okay, let's have a look at a slightly harder version of this type of question. So this isosceles triangle has a base of 36 centimetres and sloping edge of 22. Calculate the height of the triangle. So this is another question where you're not initially given a right angle triangle, you're given an isosceles triangle. But what we can do is we can create a right angle triangle. If we just split this triangle into two and just focus on one of the sides, we can think of it as a right angle triangle. So we want H, we know 22. If we know this bottom bit, then we've got a right angle triangle with two sides on it. We can easily calculate the other side using Pythagoras. So can we calculate the bottom of this? Well, yes we can, because since it's isosceles, this side will be half of that side, it's symmetrical. So half 36 and you're going to get 18. So let's draw that out. So we've got a triangle, a right angle triangle with 22, 18 and H. I would always advise you to do a sketch if there's not a right angle triangle in front of you, not a simple Pythagoras question. Okay, so let's do the formula. So H squared equals C squared minus B squared, i.e. taken away from the longest side again. H squared equal to 22 is the longest side squared, and you subtract 18 squared. If you square these out in your calculator, you'll get 484 and 324. Remember to take away and not add. I know I say that, but it's easy enough to forget that and add the things together. You get 160, and to find H, we square root 160, and that comes to 12.65.